In this lesson, we're going to review the principal payment formula. The principal payment formula is a formula used within Microsoft Excel to calculate the principal payment of a given period for an investment or loan based on specific periodic constant payments and a constant interest rate. So this is a useful formula when you want to figure out what the principal payment will be under a loan circumstance. So let's take a look at the formula explanation in detail. There's multiple components of the principal payment formula. There's the rate, which is the interest rate associated with the loan. There's the period, so PER, which represents the period for which you want to find the principal payment, and it must be in the range of 1 or another integer in the payment sequence. So let's say there were 72 installment payments. You could enter period 1 through 72. And then there's Nper, which is the total number of payment periods in the annuity. And in my example, it would be 72 if there's 72 loan installment payments. There's the PV part of the formula, which is the present value of the amount of the loan or the principal amount. And so that's the amount that it's worth today. And if it was $1 million loan, then the PV would be $1 million. The future value is an optional field within the formula, and that's the value of the loan at the end of the term. If it's left blank, it's assumed to be 0. Finally, there's the type, and the type can either be inputted as 0 or 1, a 0 representing that payments are due at the end of the period, and a 1 representing that payments are due at the beginning of the period. Let's take a look at an example to see how the principal payment formula works. So in our example, on January 1st, 2020, Flexco acquired equipment through a loan for $1 million. The loan is payable depending on the options selected below. So there's options A, B, and C. The rate of interest varies by option from 5% to 10%. Option A is at 5%, option B is at 8%, and option C has a loan at 10%. The individual applying for the loan would like to understand what the principal payment looks like under each of the options. Using the principal payment formula, we're able to quickly identify what the principal payment would be under each of these loan scenarios for any given period. Let's take a look at the options in greater detail and then calculate the principal payment. Under the first loan option, option A, the loan amount is $1 million, the annual interest rate is 5%, the number of payments per year is 12, and therefore there are a total of 72 payments across 6 years. The interest rate on a monthly basis would be 0.42%, which is the 5% divided by 12. The payments are made at the end of the period, and so that's why there's a 1 in cell E31. Under option B, it's very similar, however the interest rate is 8%, and therefore the interest rate per period is 0.67%, and there are a total of 144 payments across 12 years. In option C, we've got 240 payments. It's a 20-year loan and 10% interest rate. So let's figure out what the principal payment is under each of these scenarios for a given payment period. So let's use payment period 12 as an example. If we look at the solution, we can see that the monthly principal payment under option A in period 12 is $12,445.12. In option B, it's a third of that at $4,473.14. And in option C, it's only $1,442.76. Now the primary reason for the difference is option A is only a 6-year loan, options B and C are a 12 and 20-year loan, and therefore the payments are far less over a greater amount of time. But let's take a look at the formula and see how the principal payment is calculated for period 12. When we open up the formula, we can see that we use the PPMT formula, open parentheses, and then we plug in the formula syntax. And in this case, the rate for option A is 0.42%, so that's the 5% annualized divided by 12, because 5% is an annual interest rate, and 0.42 is the monthly interest rate, and we're representing the total payments based on the number of installment periods, which is 72 months. So we put in 0.42% for the rate. The number of periods that we put in is going to be 72, so that's NPER. The PER is what we're trying to find, and so the principal payment that we're trying to find is for period 12, so we're referencing cell E46. Next, we have the present value, which is -$1 million, i.e. that's the initial loan amount. And the future value is 0, and payments are made at the beginning of the period, and therefore we select cell E31. When we press enter, we can see that the principal payment amount for period 12 appears, and it's $12,445.12. If I were to change the period to period 11, I can see that the principal amount changes to give me the value that would exist under period 11. Now I could create a waterfall to show the principal payments over time, or an amortization schedule, but in this case I just wanted to create a simple lookup to determine what the principal payments would be based on a value inputted into cell E46. So I can easily switch this to period 1 or to period 72 or back to period 12 to see what the principal payment would be. Under option B, we did something very similar, but just highlighted the figures and stats associated with option B. And in this case, the interest rate is 0.67% over 144 months. The present value is the same at $1 million, but the payments are made at the end of the period, and therefore we choose 0 as noted in cell F31. Finally, under option C, we also want to find the principal payment in period 12, and it's $1,442. And if we open up the cell, we can see the formula is the exact same, but just referencing different values in the table. So this is a very simplistic formula to use. It's pretty straightforward. If you take a look at the formula syntax, it specifies exactly what you need to input. The only thing that I would caution that you try to remember is that the rate is not the annual rate. The rate should be the rate that is calculated based on the number of payment periods. Therefore, if you have an annual interest rate of 10%, you would divide that by 12 in order to get the monthly interest rate, and that is relevant if you're inputting a total payment period number based on the number of months, not based on the number of years. So that pretty much wraps up how you use the principal payment formula to calculate the principal associated with a loan. I often see this type of formula being used when a loan amortization schedule is being prepared, and you can use the principal payment formula in combination with the payment formula, which is something that we've gone through in a separate lesson in order to calculate both the interest portion of a loan and also the principal payment portion of the loan. Hey guys, thanks for watching this lesson. I hope you enjoyed it, and if you did, I'd really appreciate a like and subscribe from you. And if you want to learn more about Microsoft Excel, check out these videos above. And don't forget to check out our website, commercecurve.com, where we have lots of in-depth finance and accounting courses available with full training workbooks. All of our courses come with complete workbooks of lessons, examples, pre-built financial models, and training video. Hope to see you there.